Okay. Okay. Good evening, everyone. My name is Emmanuel. Today in this Python tutorial, we'll be talking about dictionaries, conditionals, functions, and loops, right? So the dictionary is a way of storing values in key value pairs. So you store your data values in key value pairs, and they are a collection of items, right? These items can be either ordered or unordered, right? So as of Python 3.7, they made the dictionaries to be ordered by default, right? But from version 3.6 downwards, dictionaries are not ordered, right? So what are the benefits of using a dictionary? A dictionary in Python lets you access a key, lets you get a value from a key at constant time, right? So in the sense that you don't have to loop through a list of items for you to see a particular item you're looking for. So you can just go to the key and select the particular key, which gives you the item for that particular key. So think of it like your normal dictionaries you have in your homes, where you're looking for a particular item and you have to like open your dictionary to a particular section and get to see the key you're looking for. And when you see the key, you now get to read the content, the meaning of the key. So it's the same thing here. We have a key value pair for dictionaries. Now, how do we know a Python dictionary, right? Let me clear my screen a little. Yes, so the basic syntax for a Python dictionary is, let's say we have a variable called first dictionary. And we just use two curly braces to signify a dictionary. So this lets Python know that, yes, I am saying the first dictionary as a variable. But let's use the first variable is a dictionary. So if you're telling Python that this first variable is a dictionary by using this, right? This open and closing braces, curly braces. Now, we can also have another way of defining a dictionary by using the dict keyword. So I can say second variable is a dict, right? So this and this actually are the same thing. The data type is dict. So there are inbuilt functions that we can use to get data type. So we can say print the type of this object. So we can say of this first variable, and when we print this, you would see that the class is a dict, right? We can see that the class is a dict. The same thing too, if I do this second variable and I run, you would see that they are both dicts, right? So we have these two ways of doing a dictionary. Now, the next question is, how do you get to have items in your dictionary? So we looked at the common way of getting a dictionary in Python. So we can say first variable is, so if we take this out and say first variable equals to, let's say, so this is how we represent a dictionary with key value items. So we say mango. Let's use a dictionary of fruits and items. So we have a basket, right? So we have a basket, fruit baskets. And for the fruit baskets, we want to count the items, the number of fruits we have in the basket, right? We have mangoes. Then let's say we have 40 mangoes. Then we have oranges. Let's say we have 30. We have purple, right? Let's say we have 3, right? So these are the contents of our dictionary. So this is another way of, this is a pre-populating the dictionary with its items. The first one we have here is an empty dictionary, right? It's an empty dictionary, and this is a dictionary with an item. So you're instantiating the dictionary and populating the items in the dictionary at once, right? So we can look at the length of each item. So let's print the length of the first variable. You should see that we have a 0. We don't have anything, no key. There's nothing in it. It's a 0. We can, the same thing for the second variable. So if we print the length of both the first one and the second one, right, we would definitely have 0 for the two of them. Second variable, you see 0. But now if I should try to print the length of the third one, if I should print the length of the third one, you can see we have 3. We can see we have 3 keys: mangoes, oranges, and purple. So if I should print the length of this fruit basket, you would see that we have 3, right? Because we have 3 key value pairs, right? So we have mango, we have oranges, and we have purple as the 3 values in the dictionary. So the cool thing about dictionaries is duplicates are not allowed, right? You can't have duplicate keys. What do they mean by duplicate key? So let me refactor this so that it's going to look neat. Yes. So remember, this is a key and this is a value. So this you can't have duplicate keys in the dictionary, in the sense that I can't say mango again and 40. Right, so you can see my ID is warning me already. It's giving me a warning. It's telling me that dictionary contains duplicate keys mango. You can't have it. They have to be unique, right? They have to be very much unique. You can't have duplicate keys in the dictionary, right? So then dictionaries don't only hold primitive data types. So when I say primitive data types, I don't mean I'm talking about ints. They don't only just hold ints, strings, and the rest. They hold, they also hold, you can also have your dictionary to have things like a list. You can also have a list of items in here. So you can have 30, you can have 50, you can have 70. So this is actually a list. So let's say this is pineapple. Right, so you can have a list right here. Not just a list, you can also have dictionaries of classes. We haven't thought about classes, so I won't be talking about classes in this tutorial. So we can have a dictionary of classes. You can have compound objects, right? So the dictionary is, the basic thing is you need to have a key and you need to have the value that the key is referencing. Okay, so then we talk about type, like using the type keyword to check that's the type keyword in Python to check what type of dictionary what kind of object this is, if it's a dictionary or if this is a list, right? So print, I can say type of 1, 2, 3, 4, or 4, 4. You see that this is going to print type of lists, right? So that is very useful sometimes. So sometimes you might also want to check if what you have is an instance of. So an instance of is, like I said, this is an instance of a dictionary. So sometimes in your conditionals, you also want to check if it's an instance of, let's say, an instance of fruit object, fruit basket, if it's an instance of a dictionary. So this is going to either print true or false, right? So since this is an instance of a dictionary, it prints out true. If I say, is this an instance of a list, it should print out a false for that, right? So these are very, very essential. So dictionaries, you can access dictionary values, right, by using their keys. in the sense that we're going to be using this fruit basket. So if I want to say mangoes, if I want to get the number of mangoes in these fruits, to access it, I will say fruit basket, then I will use an index operator here to index the key called mangoes. Can you see? So my ID is even bringing out a suggestion for me that I am looking for mango here. So this will fetch, this is going to look at the key for fruit baskets and return the value for this key, right? So if I print, we have mangoes. So dot formats. So if I print this, you'd see it says we have 40 mangoes, right? So we use this to access the value for a key in a dictionary. It's very important. Now, sometimes if we try to access a key that is not there, right? Let's say I'm trying to access apples, right? You would see that this index operator is going to throw an error. It's going to throw an error, key error, apples. So it's going to throw a key error that apples don't exist in this dictionary. Now, you'll be asking yourself, how can I mitigate this? So there is a very handy keyword called the get, right? So what the get does is exactly the same thing with this. It gets this, but the cool thing about the get is if the key is not there, I can default it to something else. So let's say I don't have a key, apples is not there, right? I can default it to, okay, none, or I can default it to 0 or anything I want. So you can see it says we have non-mangoes, right? Apples is not there. So instead of it showing an error with the indexing, so we don't have apples, then it defaults to none, right? So we can say instead of none, let's do something that's making sense. So we can say we have 0, right? So this is just going to say we have 0 mangoes, 0 apples, rather. Let's change this to apples, right? So it's going to say we have 0 apples. So we have moved from using the normal indexing, which is this, right, to mangoes, which is, sorry. We have moved from normal indexing, which is this, to mitigating our errors. Sorry, so going to try and mitigating our errors with this particular code, right? So this is going to throw a key error. This is going to throw a key error, right? So that this, we don't have this in our dictionary, right? So it's very much important. So we use the get, we can use the get to mitigate such errors, right? Or we can also use this and wrap it in what we call a try catch, right? So those are how to catch errors. Like you try something, if it fails, then hey, catch this error for me and do something else, right? So we could always use that to move forward. Then so now, sometimes we want to get the keys in the dictionary. So we want to look for, I say, I want to see all the keys we have in this dictionary, right? So I might say, I want to see all the keys in the dictionary. So I can say all fruit keys is fruit basket dot keys, right? So this returns all the keys, print all fruit keys, right? So this returns a dict keys of all the fruits, and you can see is wrapped in a list. Means that this is an iterable in the sense that I can iterate around this and just print all the keys. We'll be talking about loops, right? So we're talking about loops after these conditionals. I'll teach you how to loop through items of iterables and print and do all some things with it, right? So this dot keys returns all the keys we have. So you can see we have mangoes, oranges, pawpaw. You can see we have mangoes, oranges, pawpaw, and the rest, and pineapple as the keys for this fruit basket dictionary object, right? So another thing we can do is we can update the value for a particular key in the dictionary, right? So we can update the particular key, right? So let's say someone took a mango from this particular fruit basket, right? Someone took a mango from it, it should reduce to 1, right? So we can say fruit baskets equals to, we can say new fruit baskets equals to fruit baskets. So remember, how do we access the key for mango? We use this, right? We can access that with it. Sorry about that. You can access that with this. Then we can do -1, right? If I should print the new fruit basket, then you'd see that it's this is going to return the value for 39, right? So what's sorry, please, fruit baskets dot okay. So this is going to reduce the value for the particular mango that we have, right? It's going to reduce the value for the mango that we have to 39. So we had 40, then we had 39, right? So we can also change fruit basket itself. We can say fruit basket mango equals to fruit basket mango -1. Now, if I should print fruit basket again, you can see that now we have the first print statement is getting our way. You can see that now we have the so let me print original fruit basket, right? This, and say fruit basket. Then we can print this. We can see the original fruit basket has 40 mangoes in it, but we now in line 20, we accessed the mango key and we removed one from it, right? So someone has taken a mango from our basket and we have 39 left in the basket, right? So this is a way of accessing and updating a value and updating a particular key in your dictionary. Now we can also update our dictionary to add new objects. So we just have 4 objects in our dictionaries, right? We just have mango, oranges, pawpaw, pineapple. What if I go to the market, I have so much money and I want to add apples, right, to this fruit basket. So I can say, here I can say, we can take out these operations, right? We can take them out. Yeah, I can say fruit basket dot updates. Then what I just do is I add a key value pair. So I can say apples, then voila, I can say 40, or I can say 100 apples, right? So because why not? I have so much money. Then I can say print fruit basket. And we see that we currently have apples added to the original fruit basket object, right? So that is how we update. So the function to use is an update function where we pass in the object that's the key value to update the fruit basket, right? So sorry about that. Now, so we can decide to get items of a dictionary. So we want to get both items, that's the key value items of a dictionary, right? Then we can say it's going to return a list of fruit basket items, right? It's going to return both key and values. So we can say print fruit basket dot items, right? It's going to return all the items of, you can see this is a tuple. We have a tuple. So this is a list of tuples, right? So you can see we have each tuple is a mango and the value, oranges and the value, purple and the value. It's in the list. And so this means that I can iterate through this list and unpack this tuple with a key value and print both of them if we want to, right? So we'll be looking at loops, and there are some things to do with loops moving forward. So then we can check if a key exists in a particular dictionary. So we can say, so I just want to introduce if. We'll be going into if statements or conditionals fully, right? So I just want to say, we can say if, what do you want to check? Let's say we want to check banana in fruit baskets, right? If it's there, print true, right? If it's there, print true. But we don't have bananas in fruit baskets. So I don't expect it. I don't even expect this to run. It's not going to print this true because we don't have banana in fruit basket, right? So if I say apples, remember we added, do we have apples? Did we add apples? Okay, I have removed the apples implementation. So let's say I want to get pineapples, right? So you can see that we have true because we have pineapple as a key in fruit basket, right? Pineapple, if pineapple in fruit basket, then we can print true. But it didn't print anything initially because we did not have banana in fruit basket. So it ignored line 19. We don't have anything to do with line 19, right? So that's very much important for us to know how to do that. Now, we have this dictionary, right? And I say, okay, I don't have so much money, or you know what? I don't need a pineapple anymore, right? Please, I just don't want this pineapple anymore. I want to return it, right? How do you take out pineapple from your fruit basket, right? So what we can do is we can say there's what we call pop item, right? Pop item is an attribute to a dictionary. We can say fruit basket dot pop item. Now, what item are we popping, right? What do we want to remove? We want to remove the pineapple. I don't want the pineapple, like pineapples are too expensive. I want to cut costs. I want to take out pineapples and I want to keep the money for something else later on, right? So I can say, I want to take out pineapple, right? So I can say pineapple, right? This pops, unexpected argument. Sorry, pop rather, not pop item. Sorry about that. So pop item does not take an argument, right? Pop item removes the last key in the dictionary. But when you use a pop, you're popping it out, you're taking it out, right? You're popping the pineapple from the fruit basket. And when I print the fruit basket, you would see that the fruit basket has updated with no pineapple. So this is the original fruit basket. You can see we had pineapples initially, but hey, it's expensive, right? So I decided to like take it out. I don't want it anymore. Then you can see that, yes, look at my dictionary is updated to not have any pineapples in it, right? So we can also use the delete keyword, right? The delete keyword, we can use that to delete a particular key, right? So instead of pop, right, I can also do delete fruit baskets, pineapple, right? So this would do the same thing. This would remove fruit baskets from pineapples from our fruit basket. But there is something we need to understand about the delete, right? The delete is a very, very, very destructive function in Python. So when you're using it, you have to be careful about it. So this is what I'm trying to say. For example, I want to clear out my baskets, right? I am in my house. I am done. I'm a charity giver. I go back to the house, like, come on, look at 40 or 40 mangoes, 30 oranges, 3 purples. Like, I can't eat all this. I want to give it out, right? So I give everything out. I can now, so my basket is empty. I can say that the fruit basket dot clear, right? So I clear my fruit basket. If I print this, you see I have nothing. It's empty. That's gone back to empty. Everything is gone. Now watch this. If I do a delete fruit basket, this should also clear my fruit basket, right? Let me take out line 21. This should clear my fruit basket. You can see my ID is already warning me that, okay, name fruit basket can be undefined, in the sense that what delete does is it deletes the object entirely. Can you see? Now there's a name error. Fruit basket is not defined because the delete has deleted this entirely, right? There's no reference to fruit basket anymore, which is why we always use the clear, right? We try not to use delete most times, because sometimes when I clear the basket, I still want to have my fruit basket with me, because I can decide to go to the market next tomorrow or in the next 3 days, right? But once I use the delete keyword, this is a very destructive thing to do, right? So this destroys the fruit basket. So it means that I'm tired of this basket, right? I just want to delete it. I just want to destroy it, right? I can't have reference to the fruit basket anymore. So if we are going to be using the delete keyword, we need to be you need to know what you're doing, that once I use the delete keyword, I don't have reference to it anymore, right? You would see that you're going to have a name error, just like what I have currently. Name error, name fruit basket is not defined, right? So this is going to throw an error. But if I use a clear, watch, right? So I still have a reference to my fruit basket object, but it is empty. So we need to take note of that, right? So now, one important thing we need to understand is copying of dictionaries. Now, in Python, I can copy a particular variable into another variable using the assignment operator, that's the equals to. Now, look at what I'm trying to say. Let me create room for us, right? So we have fruit baskets. Let's forget about all these implementations, right? We have fruit baskets. Let me see if anything is going to print to the screen. Okay, nothing, right? So we have this pineapple, let's say 44, then yes. So we have this. Now I want to copy, let's say I want to copy the items of fruit baskets into another item. I can say new fruit basket equals to fruit basket. So we might think if I print if I print new fruit baskets, right? If I print new fruit baskets and I do new fruit basket and I print the fruit basket itself, and I print the fruit basket itself, right? We can see that, yes, we have it's copied, right? It looks like it's copied, but take note, this is not going to copy. How do we know it's not going to copy? If I do, there's what we call an ID in Python, right? The ID, what the ID does is it returns the memory reference. It returns the reference of the object in your RAM, right? Because when this thing runs, they run on your RAM. It returns the memory reference on your RAM, right? So if I do the fruit basket and I do the ID for the fruit basket, sorry, and I do the print the ID for the new fruit basket, you can see that they will be referencing the same address on your memory. Now you can see they are referencing the same address on your memory. What this is just doing is it's making a pointer, right? It's saying that, okay, new fruit basket points to the memory address of fruit basket. When I try to print new fruit basket, they reference that pointer and print the value of what's there. So this is just pointing to fruit basket. It's not even copying it, right? So this brings the idea of what we call shallow copies and deep copies, right? There are two types of copies. We have shallow copies and we also have deep copies, right? What are the difference between shallow copy and a deep copy? A shallow copy constructs a new compound object, right? And then inserts references into it, the object found in the original. So what it does is, what a shallow copy does is, okay, I want to do a shallow copy, bring this new object, right? Make it have its own memory object, but the content of that memory object reference the original one. So it doesn't fully copy everything in the original. So what I'm trying to explain to you is, you see here that we have this. If I do dot copy, right, and you would see it will return the two different addresses. These are two different addresses, right? These are two different addresses, but this is a shallow copy, right? In the sense that if I have a dictionary here, or I have a compound object here, it will just reference this compound object, right? It will not even change it. This is okay for now because these are simple variable, these are simple data types, right? They are just ints, right? So if it's going to change, it's going to change it all. But sometimes I want to have a copy, like a deep copy. Now, what a deep copy does is it creates a reference of its own, right? A deep copy constructs a new compound object and recursively insert copies into it, the objects found in the original. So it copies it entirely. Now, this is what I'm saying. We can have compound objects here. If I say bad, so bad pineapples, I have 10, then I have good, right? I have good, I say 44. Now, if I do a copy to this, remember I'm doing a shallow copy. If I should say fruit basket pineapple, right? I want to change the pineapple, right? The referencing of the pineapple. So since this is going to return a dictionary, I can access this bad by doing a nested operation like this, right? If I say 30, so what this is going to do is this is going to go to fruit object, look for this key. What is this key? Pineapple, right? Then since if you look for this key to return this value, and my value is what? Also a dictionary, I can still access this key again by saying what? Bad. This will return the bad. If I change it to 30, right? And I print fruit object and this and the new fruit basket again, right? Let me print this. If I print the new fruit object, you will see that it is changing both 30, right? But I just referenced the fruit basket and changed the 30, right? It's not supposed to change new fruit basket. And why this is happening is because we have a copy, right? We have a copy of this. But if we do a deep copy, right? If we do a deep copy of this, if I do, it's a module in python.deep copy, and I do a deep copy of this, I import this, right? So I import this, import copy, and I change 30. Let's watch this. Now, can we see the new fruit basket still has the original 10, right? It still has the original 10, but the old one that I changed on line 40, I changed it, but it did not change the object of the new fruit basket. It only affects the fruit basket itself. So that's very much important for us to know. Like when you try to copy and you're trying to, and you copy both aspects, right? So the next thing on our list is, that's all for dictionaries. The next thing on our list are conditionals, right? What are conditionals? Conditionals are very simple. You just need to have them. You just want to check if this statement is true or if it's false, right? If this statement is true, do something. If it's false, do something else, right? That is what conditionals are. That's the basic thing about conditionals. So I just want to check that, okay, if I want to do this, you should print this, or you should run a function called this, or you should run this, or if it's not true, you should do that. So this helps us in helps us in decision making, right? Where you can run for a particular condition, and if the statement is true, do something, otherwise do something else. So it's a very simple thing to do in Python, right? So we use the if expression, right? So if the expression is true, right, do something, right? Then if the expression is true, just do something. So for example, I can say number equals to 10, right? So I can say if number is greater than 2, is greater than 4, print yes, number is greater than 4, right? So if I should run this, you'd see that yes, it tells me yes, number is greater than 4. And this is true because if I replace this with 10, right, you can see that number is actually 10. So 10 is actually greater than 4, which is true. Yes, 10 is greater than 4, right? So this is a basic conditional statement, right? I want something to happen if this number is greater than 4, right? Or if this number is greater than, so if this number is greater than 10, you should do something. 10 is not greater than 10, so it's not going to do anything, right? It's just escape, right? It's just going to check and leave out line 4 without doing anything. Now we have what we call the different operations to check for conditionals. We have the equals to, double equals to, we have the greater than, we have the lesser than, we have the greater than and equals to, we have the less than and equals to. Okay, so give me a minute. Let me update something on my settings. Come in, fonts, Fira code. Okay, that did not apply. I'm supposed to save that. Font, Fira code. Yeah, that should have applied. So this, what this is doing is checking if something is equals, if the first operand is equals to the second operand. This is checking if the first operand is greater than the second operand. This is checking if the first operand is less than the second operand. This is checking if the first operand is greater than or equals to the second operand. This is checking if the first operand is less than or equals to the second operand. So now, if I introduce this, right? If I introduce this, if number is greater than or equals to 10, right? So this should run because 10 is actually equals to 10. 10 is not greater than 10, but 10 is actually equals to 10. So this should run successfully, right? Like, yes, 10 is greater than or equals to 10, right? So if I update this, you can see, yes, number is greater than or equals to 10, right? So now we have what we call an else statement. Okay, if this is not true, then do this. Like if this condition we're trying to run is not true, then do something else, right? So if number is not greater than or equals to 10, we can say else, right? prints. So we can use the format. Sorry, we can use the format. We can say number is not greater than 10, right? So we can see that 10 is not greater than 10. We are expecting line 6 to run, right? So yes, you can see that, yeah, is 10 greater than 10? No, right? If it's not greater than 10, else do this, print number is not greater than 10, right? This is a basic conditional statement, right? Most times we have a lot of conditional statements making our logic do whatever we want it to do, right? So we have what we call a nested if statement. So the nested if statement is, okay, if number is not greater than 10, I can also check, I can say else or elif. So else if, right, number is equals to 10. So this gives us more power. We can say print, yes, number is equal to 10, right? So is number greater than 10? No, number is not greater than 10, right? It will not run this, right? So is number equals to 10? Is 10 equals to 10? Yes, 10 is equals to 10. Then it will run this and not run this particular one anymore, right? So we can see, yes, number is equals to 10, right? So that is for basic conditional statements, right? So I've explained how to use an if and how to use an else. Also, we have explained how to use an else if, right? So yeah, so I don't know. So yeah, we can also do this in a minimal statement, right? So we can say, so Python is very great, right? We have a Pythonic way of doing a lot of things, right? We can say, so just watch this. We can say print if number is greater than 10, else. So we can say print, we can say true or anything if number is greater than 10, else false. So what this is going to do is we are checking if number is greater than 10, right? If number is greater than 10, print true, else print false, right? So this is going to print a false because number is not greater than 10, right? So you can see that we've broken all this 3 to line 8, 5 lines into just one line, right? So we can still take this, right, and say, instead of print true, we can say, yes, number is greater than 10, else we can say, we can just do this, else number is not greater than 10, just one line, right? Then it's going to print 10 is not greater than 10, right? Capiche, like very simple. So we can do this. Let's see if we run 10 is greater than 4. Yes, definitely. Yes, number is greater than 10, right? So that's very, very much important. So so that's all we have for conditionals, right? The next thing we'll be looking at is loops, right? Beauty, what a beauty, loop. Now, what are loops, right? Loop is very simple. They are statements that are executed sequentially, right? So the first statement in the function is executed first, followed by the second, and so on, and so on, and so on, and so on. So it happens, it keeps happening, this happening. They happen for several number of times, right? So in Python, we have the while loop and we have the for loop, right? So the for loop happens for a given period of time, in the sense that they terminate, right? They end for as long as we have gotten to the end of that particular reason or or container, right? Let's say we are looping through an iterator, right? An iterator is it's a very good example of what we're going to be looping through. So the for loop is used for iterating over a sequence, like a list, a tuple, a dictionary, a set, or a string. Yes, I don't know if you were taught in the last class, you can iterate through a string, right? That's the characters in a string. You can iterate through it and get to do whatever you want to do, right? So we have how do we use a for loop, right? Let's say we have a list. Let's say we have a list of names, right? We have names. We have Xylox. We have Tuni. We have Big Daddy, of course, right? So we have these names. Sorry for that. We have these names. Now I want to print the names that we have here, right? This is a loop. I want to go over everything in this list, right? And print each item in this list, right? First of all, we can check. So, okay, now this is a very good, we can say if the instance, let's use an if statement with our for loop. So if instance of names is a list, right? So remember where I introduced if instance. So if instance of names is a list, this is true. If it's a list, then I can now say for name in names. So we can see that we have names as plural. We have different names, collection of names. So I can say for name is a single name. Then I can say in names. Now, what this is doing is it is iterating. It is going through these names every single time. The first time it will go through the name, it will assign it to a variable called name, right? Then we can now do print name, right? So this is going to check if our names is an instance of a list, then do this for name in name, print this, right? So let's see what happens. So can we see it prints Xylox, Tuni, Big Daddy, right? So let's see what's going on in depth here. So if I should bring my debugger, if I should debug loop, right? So it's coming up. So yes, so this is my debugger, this is my stack, right? So you can see my stack, I have 3 items, Xylox, Trini, and Big Daddy. It has a length of 3, right? Because we have 3 items in it, right? So if I step into my code, right, you can see for names, you can see what I was saying. For every time it goes into names, right, it goes into names for name. So he assigns Xylox as the first name into name. We can now print the name, right? So we can see here also on our stack trace, right? You can see that name is a type of string, right? Then we can now print the value for name, right? In our console, you can see Xylox was printed, right? So if I step into the code again, it's done with the first one. It will go to, after Xylox, what the next thing we have? The next thing we have is tuning, right? It steps into that. You can see it now assigns, it discards the first variable, that's Xylox, and it assigns tuning into names, right? So you can see we have tuning here and it prints it, right? So it goes to the third one and it does the same thing. It prints, guess who? Big Daddy, right? It prints the 3 of them. And once it's done, it has gone through the iteration 3 times because we have 1, 2, 3. That's gone through it 3 times. Then once it's done, it stops, right? My debugger has ended, right? So the debugger is also a very good way to know what is happening with your code. You can step into your code. Sometimes you might have logical errors. You use your debugger to step in to see what is really going on in the background. Now, so there is we should know that your computers start reading numbers from 0. So what does that mean? It sees this index as a 0, sees this index as a 1, sees this index as a 2. in your computer, but for it to be readable for human beings, the program tries to, as a language, tries to tell you that, okay, this is a length of 3. It starts from 0, 1, 2. So 0, if you count it, 0, 1, 2, that is 3 items, right? But your computer starts from 0. Very much important for us to know that, right? So like I said, we can loop through a string, right? We can comment this out instead of deleting it. We can say for char in mosquitoes, right? Print char. So what this would do is it will go into your into this string and print every single character that we have. So char is just a short form for character. So remember, so you can see it prints every single thing out. It printed MOSQ. So it's you can also iterate through your strings, right? So we have what we call statements in your for loop. We have the break statements. We have what we call statements in general. We have the break, right? We have the continue. We have the pass, right? So we're looking at these 3, right? So let's say I want to break out from this. If I see U, if I encounter a U, right, I want to break out of this. So I can say if char equals to U, right, I should just break, right? This will stop running. It will not go to UITOES. It will just break out of everything. So we just have, so we can just print char so we know what's going on. So if you see, we just have MOSQ, right? So it comes the first time, it sees M, right? It checks, is M equals to U? No, it doesn't run this. It prints M, right? It checks O. Is O equals to U? No, it doesn't run this. It comes here. It checks S. Is S equals to U? No, it runs it. It checks Q. Is Q equals to U? No, it runs it. Then it checks U, right? Is U equals to U? Yes, U equals to U. Then what do I have here? Break. Just break out of this, right? Don't do anything. So if I change this to a continue, right? Watch what's going to happen. Now, you can see that U was omitted, right? MOSQI. So it's saying that instead of, if I get a U, if I get to this point of U, continue, that means I should not do anything here. Like I should not do anything down here, right? I should just omit this, every other thing. I should just omit every other thing and continue to the next iteration. That's I. That is why we have MOSQITOES. So the idea for pass, right? What pass does is we just say, don't do anything, right? Just don't do anything internal to this place. Continue whatever you're doing, right? In the sense that if I don't want to throw an error, because if I take this out, Python will return and will tell me that there's an error, right? But I don't want to do anything. Maybe later on I want to process a code here, but I don't want to do it now. So I can just say pass, right? Sorry about that. So I can just say pass. So nothing is going to happen. It will still print out this U, right? It still prints it out, do everything. So those are the differences between the pass, the break, and the continue. Very much important, right? So there's what we call the range function, right? The range function is we loop through a set of code a specific number of times, right? If you want to loop through a code a specific number of times, you can use the range function. So what do we mean by that? So we can say for number in range 6, or no, 8 is too long. Let's use 8, right? We can print number. So what it does is, what this does is it goes through number then it prints everything in number, that this range of numbers, like it goes 1, 0, 1, 2, 3, 4, 5, 6, 7. Now, the thing with range is this 8 will not be printed. It excludes the number, like the last number you're seeing, that's 8. So in this case, we have 8. So it excludes it. What we have is 0 to 7. This will print 0 to 7. It will not print out 8. 8 is exclusive. So the last number is actually exclusive. It's not included, right? So we can also define a start and a stop. We can say do a range from number 2 to number 8, right? When we run that, it will start from 2, 3, 4, 5, 6, 7, and not 8. If you want to include 8, we just do 9. So this is just going to go to 2 to 8, right? Now we can do what we call step. Now, what we mean by step is we want to go maybe increase by 2 or increase by move by 2 or move by 4, right? So we can do steps of 2, or let's say steps of let's say if we do 2 to 50, steps of 0 to 50 rather, steps of 5, right? So this will do 0 to 50, but she's going to have, can you see, 0, 5, 10, 15, 20, 25, 30, 35, 40, and 45. It will not print 50 because I said the last one is not included. So the next step after 45 is actually 50. It won't print it. If I do 51, then 50 will be printed to the console, right? So that's very much important to note. So we can also have what we call the else in the for loop, right? We can say if we're done processing this, we can say if we're done processing this, then else prints loop processing done, right? So once we're done, this tells us that yes, the loop processing is done, right? We are done with that. So we can always do this maybe when we are done iterating everything in our items and we want to do something extra right after then. So it's very much important. Then we have something called the nested for loops, right? So the nested for loops is let's say we have combination of food items, right? So we have food one, we say white rice, then we say spaghetti, right? Then we say beans, right? So we can say food complements. We can say we eat white rice with stew, right? We eat spaghetti with we can eat spaghetti with egg or what have you. Then we can eat beans with bread. Doesn't like beans and bread. Doesn't like beans and bread. So we can say we're going to loop through. We can say we want to loop through for food in food one, right? Then we can say for food complements in food for complements in food, for complements in food complements. Sorry, I would update that currently. So for complements in food complements. So I want you guys to see something. Then I can say print food, comma, complement. Now watch this. Sorry, this is supposed to be inside, right? So what this is going to do is this is going to go into food one, right? White rice. Then we're now nesting. We're now saying for now do the same thing. Complement should go inside this, right? Then print this. Now this is going to do white rice, stew, egg, and bread, spaghetti, stew, egg, and bread, beans, stew, egg, and bread. Now, I would look throughout the debugger to see what's going on. So as you can see, white rice stew, white rice egg, and white rice bread, spaghetti stew, spaghetti egg, spaghetti bread, beans stew, beans egg, and beans bread. Now, for me to explain what's going on, right? Let me use the debugger for us to see this. Now, what this is happening is anytime I go into the food, right? I step into this, the food is white rice, right? So we can see that food is white rice. Now we are now saying that complement, can we see complement is stew, right? It's going to print what? White rice and stew. Now, this is only going to jump out of the for loop if this inner one is done. We have 3 items here, right? It's saying for food, for complementing food items, run this as long as we are done with this particular one, right? So it will still be under white rice because we're not done iterating through food complement, right? It should enter food complement again. What's the next thing in food complement? Egg. Can you see? So it's going to, the first one is white rice and stew. If I print it now, you can see complement is now egg. It is going to finish everything, loop through everything that is inside here before it goes to the next item. This is very much important with nested loops, right? You want to have everything done in your nested loops and make sure that yes, once this is done, once this and this is done, it should go out of the loop and process, come inside the loop again, do it for the next item. So if I should do that, you can see white rice and bread. Now that we see that bread is the last thing, we are going to jump out of the loop. Now watch, can you see? Bread is, we are done with the contents. What's going to happen? Remember, we're still in white rice. Then this will now go to what? Spaghetti. When this goes to spaghetti, it will do the same thing again to start afresh with stew. Right? Can we see stew? Then print for spaghetti and egg, then print for spaghetti and bread, right? The bread is the last thing. What happens again? It goes out to what? To look for beans, right? It goes out to look for beans. Then you can see it does beans and stew, beans and egg, and beans and bread. Then it checks. It checks this. This is beans. Do we have any other thing after beans? We don't have any other thing after beans. Then what it does is it jumps out of the loop, then prints loop processing done. So with this, we can have multiple for loops. You can have for loops on for loops, for loops on for loops on for loops on for loops, like depending on how many layers you want to do, right? We can always do this, but this is bad code. Please and please do not do this, right? Your code will be very, very slow because it has to run through a lot of stack spaces used. It has to run through this and recursively and go out and come in, so let's try to avoid having at least more than two or three nested loops within each other, right? Very much important. So now there's what we call enumerate, right? Enumerate, what enumerate does is we want to print the key, we want to print the index, right? The index and the item. So we say enumerate and we enumerate food. What this does is we print index of index and value of value, right? We can use the format. So I am very flexible person. I can use the format string. I can also use the F format, right? Then with the format, I can replace a value here to make it like a kwarg or an args. So anyone. So we can do index, we can do food, right? So if I should do this, what the enumerate does is it prints my index for me. And so you can see the index is 0. What is my first index? What is the value of my first index as white rice? The index is 1 plus the value is spaghetti. The index is 2 what's the value bins. So the enumerate is a very, very much important value to use, right? So the next thing we'll be looking at, I believe we looked at conditionals. We've also looked at loops. Then we are coming to something more interesting called functions, right? Functions are very much important, right? They compose and they do a lot, like they're building blocks for complex code, very much important for you to understand the concept of functions while moving forward in your programming career, right? So a function is a block of code. So it's a block of code which only runs when it is called. So you have this thing waiting, right? It's waiting. It doesn't do anything. It's waiting for it. You have this awesome thing that needs to go on, right? It doesn't do anything until you call it. A good example is, let me use something relatable, is you want to eat, but Sapa the town, Sapa is everywhere. There's no money, right? But you're waiting for money to come in, right? You've done everything, you're waiting for that perfect time, right? Where they will send you the money so you can go and buy food, or you can go and buy that particular thing you want, right? So the moment the money comes in, right, your account tells you that you have a credit alert, that money is inside your account. The next thing you do, you've activated yourself to be like, yes, let me go and buy this food. That activation moment is what we call a function call. Is you have been waiting to do this. You've already had yourself pre-lined that you want to do is a bunch of stuff. That is what we call the block of the function. These are the things you want to do, but you can't do them until it's being called. So that is a very much important thing to understand. Now, you can pass data known as parameters into a function, and a function can return a data also. So in this, what is that saying? When you pass data into a function, so in the sense that you want to do something, right? You want to buy this awesome shoe, or you want to buy this awesome bag, but you don't have this money, right? The data that is being passed in is the money itself. The money is coming into your plans, right? And you get to execute this thing. And what are you executing? The buy function. You want to buy the shoe, but the money has to come in. So that's what we call known parameters. Like you can pass data into the function, right? Then what is your return? Your return is the shoe itself that you're getting from the store, right? Very much important for us to understand. Now in Python, the def keyword is what we use to signify a function, right? So we can just say simple function, right? So this is a function, this is a function. So now we can see that pass statement that I said. So this is not going to, if I don't put this pass, Python will say that is an error, it's not completed. So I can say I'm going to come back to do something on this function. Let me just go around and do something else. So this is a simple definition for a function, right? This is how you define the function. The def, then the function name. That's our function name here is called simple function, and we have open and curly braces. Then we have the definition for the function, right? So this is a function definition, a simple function definition, right? And that's about it. So the function, we can say prints, yay, first function, right? So if I should run this, nothing will happen because I have not called this function, right? Nothing will happen because I've not called this function. Now, how do we call a function? Now, you just have to look at the function signature, right? The function signature, this is function signature, right? And this is how you call the function. You just write the name of the function, then you open and close the parentheses. So this is, if I run this, this is going to call the function, right? Yay, first function, right? So this is how you write a function, and this is how you call a simple function, right? So there are things we call parameters or arguments, right? it's we interchange them, but I want us to understand one thing. A parameter is not an argument. Let's take note. Parameters or arguments. Developers, we interchange them. We say parameters, we say arguments most times. When people say that, they're trying to mean the same thing, but they are not actually the same thing. Now, a parameter is the variable listed inside the parentheses of the function definition. Now, remember, where is our function definition? This is our function definition. This is where we are defining the function, right? It has this function signature, right? The parameters are the variables listed inside the parentheses in the function definition, while the argument is the value that is sent to the function when it is called. Remember, this is function definition, right? So I'm explaining arguments and parameters. This is not just limited to Python alone, right? This is everywhere in programming, and this is function call, right? So the function definition, right? The parameters are passed here, then the arguments are passed when the function is called, right? Function definition, function call, the same function signature as we can see. Now, how do we pass parameters to our function, right? So we can say name, right? So this is a parameter to our function. I can say hello. I can say hello name. Now we can see that my ID is warning me. It's telling me that parameter name on field. That means my parameter, which is called name, I've not passed it as an argument here. So I can say the name is, I can say my inputs, name inputs is enter your name, and I just pass in name input. So Python is, my ID is complaining of clean code. So it's a PEP guideline, PEP 38012 2 blanks line have to be after a class or a function definition. So, right. So if I should run this, you can see I'm passing this as an argument. Please take notes. I'm passing this as an argument, right, into this simple function parameter. So this is the function call. Remember, you're passing the arguments on your function call, but this is the parameter. Take notes. So if I should run this, it's going to ask me for, it's going to ask me, I didn't put my inputs so that it can pause my execution, right? Sorry about that. So it's going to ask me, then I say Manny, then you can see hello Manny, right? So if we want to know what's going on, like I said, we can use our debugger to check. We can debug simple function, then so yeah, the debugger is asking me for my name, enter your name, right? So I put Donjo, right? If I put Donjo, I put Don, right? So you can see my input name is Don, right? Then once I step into, once I step into my code, then you can see that this is calling. Can you see now? It has now passed in the arguments. These are the arguments. This is argument I passed in. It has now passed the arguments to my parameter, right? So it's now calling the function. The function is lying there once it's being called. So you can see that the name Don is now replaced, right? The name input Don is now replaced by the name. And if I step in, you can see it's printed out my code. Then once I step in again, this is going to take out my function from my stack trace to clean up everything, right? So it's clean up my code. Then Python garbage collection has done the rest for me in the background, right? So this is a basic function, right? So I can have multiple parameters, right? I can have multiple parameters for my function. So I can say name, I can say first name and last name. So I can say, hello, first name. Are you sure your last name is last name, right? So we can do this. So now you can see it's telling me that now we can see that my ID is warning me and it's telling me that last name is on field, right? So I can say enter your first name. Enter your first name. So this can be first name, and I can duplicate this and say last name and say enter your last name. So I can do first name, last name, right? So if I run this, I say enter my first name, Don, enter my last name, Joe. So you tell me, hello, John, hello, Don. Are you sure your last name is Joe, right? So to provide the format that, we can put a comma there. You can say, hello, Don, Don, Joe. Don is going to be angry with me. I'm using like two capital letters. So yeah, hello, Don. Are you sure your last name is Joe, right? So we can see that we can do things. So we need to understand one thing, right? For you to understand what a function is, please and please let your function do only one thing. Let your function do only one thing. You see people, their function is processing a lot of things, and you're like, why can't you just take this out, right, and make another smaller function that does a unit thing, right? Process a unit thing. So for you to have like for your code to be understandable, right? You need to first of all understand how to give proper variable names, right, and proper function names, right? So you can have multiple checks and you can have smaller functions. What this helps you do is when you extract these things into smaller functions, you can debug your code better and easier so you know what is going on. But please and please don't let your functions have bulky implementations. Let your functions do one thing and one thing only, right? So there's what we call arbitrary arguments. We have the arbitrary argument and the arbitrary keyword arguments, right? So we have def people's name, people names, right? Then if you see args like this, people like using args. It's a default. So you can see we have just one star. It's a default thing in Python, right? If I print args, let me show us something. If I print args, right, what I can just do here is this is going to take multiple arguments, right? It's telling me that I can take multiple arguments here. So I can duplicate this. Instead of simple function, I can say people names. Now you can see that it's not complaining because I'm using a star args for it. So if I print this, the star args, let me just take this out. Let me put defaults to them, right? So I can take this out and delete both of them, right? So I can say Manny, then Johnson, right? So if I should rerun this, you can see now, right? This is the first. Let me take out this. Let me not call this function people names. You can see I'm printing the args now. Watch. The arg returns a tuple, right? I believe we've been taught what a tuple is. It returns a tuple, right? So it means that I can take multiple args, right? If I do first name, and args, then I do middle name. If I do middle name as devs, let's just use middle names as dev. If I do middle name, now watch this. Now, if I print first name, right? Then I print args. Now watch. you can see that my first name is Manny. Now, you see that this args, right? This args now takes everything that we have here. Can we see? These args take everything that we have here. That is why we have Johnson and Devs. So we can have this, then we can now say last name equal last name, comma, middle name. So what this is going to do, this is going to unpack our tuple, right? So last name, then we can do print middle name. So this is going to unpack our tuple and print all the names, right? You can see that we have that in the args, right? We have all these things in the args and we can print them out. Now there's what we call the kwargs, right? The keyword arguments, right? Keyword arguments are the same thing, more like args, but now they have like they are going to return dictionaries instead of tuples, right? So remember, we are returning tuples with this. They are going to return dictionaries instead of tuples, right? So this is returning a tuple. So to verify this, we can say print type of args, right? So you can see this is returning a tuple, right? So what we can do is now when you're calling your functions, right? There's what we call named arguments. These aren't named arguments. So if the way you're passing, so please note, the way you're passing your arguments is how your function is going to see it. So let's not use args, let's use last name, comma, middle name, right? So if I print last name, we know how this is going to work. This is going to then middle. Let me just take this, get rid of this guy and print middle name. So if you be the way we pass this in, right? First name here will be passed into first name. That's Manny, right? Last name is going to pass into last name. That's Johnson. And middle name, which is Debs, is going to be passed into this middle name, right? So the way you pass it in is the way it's going to take in the parameters. Now, sometimes you might not have the luxury to start passing in it directly. So Python has what we call named arguments, right? So if I do people, so what name argument does is I can specify, I can scatter it, right? I can call middle name first, but for me to call middle name first and still be referenced, I would do a middle name equals to, can we see, equals to middle name. So in this way, Python is now saying that, okay, instead of me arranging it, I can say last name equals to last name, then first name equals to first name. Now, this way, Python is not saying I have to look at middle name and replace middle name as first name. No, what this named argument is saying is you can see that the named argument is middle name, the parameter middle name. See, middle name of functions of middle name, right? Any. Right? I will talk about what this is in typing, what we call Python typing, right? So middle name, you can see that this middle name is the same thing as this middle name here. So it's saying that anywhere I see middle name, equate that middle name to this, right? Anywhere I see last name, that's the same last name here, equate it to this. Anywhere I see first name, equate it to this. Like very important for us to understand. So with this, we are going to have what we call the named argument being passed in. So if you run this, you see that it's still going to be the same thing, right? Let me clear this out. It's still going to be first name, Manny. You can see first name, Manny, right? Last name, Johnson, then middle name, Debs. Very much important. Now, some people can, so if we can go a little bit further and let me copy this, right? And print this middle names underscore like new, right? We can say, you know what? Let me just pass in args and kwargs, right? Args and kwargs, right? They're very like when you see a lot of Python code, you see them passing args and kwargs. So some people might not always want to use args, but it's just something known by Python devs. I can say names, right? Still going to do the same thing. It doesn't have to be args or kwargs, right? We can always change it. So if I print args, if I print kwargs, right? I print kwargs and I take this guy out. If I run this middle names new, right? If I run this, you can see that my args is empty, right? I'm not passing, so there are no arguments. But my keyword argument, can we see my keyword argument, my kwargs, they look at this keyword, right? They now put them in what we call a dictionary. Remember the dictionary we did today, right? They put them in what we call a dictionary. So it looks at my keyword. That's why we call them kwargs, keyword arguments. These are just arguments. So it looks at this. If I should do so, the beauty about this, I can put endless. I can put Chioma here, right? I can put Chioma here. Now, if I put Chioma here, this is just an argument. So we are going to, our tuple will be updated, right? So if you look at our tuple, can you see Chioma is there, right? So this is arguments, a list of arguments. This is a dictionary of keyword arguments, right? So you can see middle name, dev, last name, blah, 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 Johnson, first name, money. So here we can now do, since this is a dictionary, remember, we can now do print kwargs dot get. What are we getting? We can now say get last name, right? So this is now going to print the last name that is being passed, right? So you can see it's now printing Johnson, right? So you can see how we are now layering on what we've done so far and how to get things done. So sometimes we might also pass in a list. You can pass anything. You can pass a function. You can pass a function reference, right, into your function, right? You can take a function and call a function. So what I mean by that is we can say, so you would see people do this. We can say def calling function. Sometimes because sometimes you might not want to invoke a function, right, into a particular function. So you might just say calling function should take in a func, right? Then this should just call func, right? This should just call func. So what is going to happen is this will call func with, let's say we have Jones and Franklin, Franklin. Then we can copy this just to save time, right? So we can do, yes, so we can copy this to save time. Then if we're calling func, right, it's taking a function. So we can say func, calling func, then passing what function do we want to call. So remember, which function is this dynamic, right? It's this function here that has kwargs and args, right? So we can call this, we can pass in this particular function. Sorry, I'm passing this particular function. So this is going to call people's name. So we are passing in the reference to that. Can we now see? So it's calling Jones, it's calling Franklin, then middle name, last name, first name, right? So it's practically calling this function, right? For us to understand this, we can call our debugger to, hey, our very good friend, we want to know what's going on here. So what we can do, it's already running, sorry, we are supposed to put our breakpoint here. So this red thing is called breakpoint. So now, a minute, right? So we can see when calling func is called, so calling func, can you see? So it's passing the reference to you can see it's called a function type people's names, right? So you can see the people's names at this address, right? You can see the address. It's passing the reference. It's passing that address of this function. So when we get inside here, it's now going to call that function in that address, right? So you can see this is the function we passed in. Can we now see it's now calling it? These are the args and these are the kwargs, right? These are the keyword arguments and these are the args, right? Can we see? So we print them out one by one. And once we are done with them, then it jumps out from the function, clears our stack, and exits the program, right? So very much important. Now, another concept is return value. So all this time, we are not returning anything from our function. Our function is just doing one thing. It's not returning anything. So sometimes you might want to process one or two things and return something from the function, right? So let's say we have a function that squares a value. So we say def square function that it should take in a value and it should square that value, right? It should square it. So you can return value. So it should just return this. So we can see we have a keyword called return. So before we've been doing what we call prints. Can we see we have been doing print, right? So what return does is it will do this, then return what we've done to to a variable or anything that is requesting what is to be done. So I can say squared value. I can say squared value equals to square function, then passing, let's say 10. 10 square is 100. So I can just do a print squared value, right? So this should return 100, right? So this calls square function and multiplies it by 2, right? And multiplies it by itself. That is the square. So I can do this 3. This is cubic, right? I can do 4. I can do 5. So right. So if you can see the squared value, you can see is assigned to this function called passing it 10. So it's going to jump into line 34 to call this. So you can see the value that has been passed is 10. Then it's going to do 10 squared, right? Then return the value back to this square value. And as you can see, square value is 100. Square value is 100. Then we can now print what is square value, right? So we can now print it out to the console, 100, right? So very, very simple, very easy, right? So these are just building blocks of our functions, right? Then the last thing we are going to be talking about today are what we call Lambda functions, right? Lambda functions are just anonymous. They are small anonymous functions. You don't need to. A perfect example is this thing I did here, this squared function. I can do it in what we call a Lambda function, right? I don't need to have a name that is being called, right? So how do we do a Lambda function? So here I can just do squared value equals to lambda, then it takes in an argument x, then it just does x squared. So this and this are the same thing, right? So this is going to return a function, right? It's not going to return the value. It will return a function. Please take note. The lambdas always return a function. They don't return a value that has been processed. They return a function. Now we can also do squared value, then passing 10, right? Can now do square value or passing 10. So please take note. We need to take note of this, right? So we can now do not align, use a def. Do not assign a lambda function as a def. They're just saying they're just giving me a warning, but you can see that it's doing the same thing, right? So I'm passing in a 10. What happens is this 10 is passed into this anonymous function. So it's called anonymous function because this function does not have a name, right? So we now assigned it to, and that's more reason why it's even screaming that, don't pass it, don't pass it a square value, so I pass it to a name, but yeah, man, I can do what I want, right? So I tell the computer what to do, right? So yeah, that's basically it. So yeah, I think that's going to wrap up what we have for today, right? We can ask our questions right now.